This is the third assignment in factoring. And again, you need to do as many of these as you see fit. And as we go down this list, they get each a little bit more difficult, but the procedure remains the same. And I'm going to give you some in the second part of this, factoring any cubic, where you'll really be put to the test. Cubics will not be on the quiz. Quadratics will in their entirety. Okay, so remember, we're trying to find rational x-intercepts. And when we run this through and we don't get any x-intercepts, no real roots, or we get irrationals, these big long decimals, they don't terminate, they don't repeat, and you can't convert them to a fraction. In both of those cases, you have a prime quadratic. So I added in here this b squared minus 4ac, just so you can relate that to some of the other stuff. It's not really necessary. This one ends up being no real roots in -71. So when that's negative, it tells you there are no real roots, it's prime, and then we're on that certain part of, we're over here. This is the b squared minus 4ac less than 0 part. This is the b squared minus 4ac greater than 0 and not a perfect square. And then that's the b squared minus 4ac equal to or greater than or equal to 0 and a perfect square. Okay, so these are, I'm just going to leave that there, so we'll know what to see when we get it. So this is 0 here. So what is b squared minus 4ac? What is that? Well, b is 40. Literally, you do that computation. 40 squared minus 4 times a is 16 times c is 25. You get 0. So in the case where you get 0, you are going to get two identical factors and one x-intercept. So this is going to be 4x plus 5 times 4x plus 5. What I want to try to do is one of each of these. There's really 4. Okay, so there's two cases here when you get 0, when you get the identical factors, and then one case where the factors are different. Okay, so here we get 20, and the x-intercepts are going to be not nice, -2.2 and 2.2. This is not a perfect square. We can't take the square root of that. So again, we have prime. This is this case right here. Irrational roots. And let me just find one that works. So number 5, 25. I can take the square root of that. This is going to work. -1/2, -3. Don't forget to check for the common factor. Do not put, so 2x times x is 2x squared, no common factor. Do not do this. You will get a very bad grade in this class if I see you do this. Some online sites do this. It is not the factoring because x times x does not give 2x squared. Oh, some people put a 2 in front. I know some of you are smart enough to figure that out. I don't like that either. It's not really a common factor. So factor correctly, that's what I want. And now you've seen one each. One where it's prime because there is no x-intercept. One where it's the double root. That's a b squared minus 4ac is 0. One where you get irrational x-intercepts and the b squared minus 4ac you can't take the square root of. And then anytime it does factor, the b squared minus 4ac, you're going to be able to take the square root of it. You can 0, It's just 0 tells you you have two of the same factor. So you can complete that. Then there's extending the idea. Oh boy, what is this about? So I'll do a couple for you, and I'm going to circle some problems here. 4, 5, 9, and 10. The hierarchy is in your notes, so you can just maybe try to pencil that out by memory. What's the process of factoring? So when you do this, and you're using the app here, Polysimul 2, you need to now go to order 3. The online, you just type it in equal to 0. But here you got to go to order 3. And then you have 4 values to put in under addition, and we're following all the same rules all the time. Now hit decimal to fraction. So 4, -5, and 3/2. So I'm going to do the 3/2 first. 2x minus 3, x minus 4, x plus 5. We just factored a cubic. Now 2x times x times x is 2x to the third. There's not a common factor there. Most of these have a full factoring. The 4 that I circled have a partial factoring, meaning that we get one x-intercept and the other 2 don't work very nicely. I'm going to do 2 of these. You're going to do the other 2. So number 4, clear this out, 1, 4, -31, -4. Notice that 2 of those are irrational, so you cannot write factors for those. When I say x-intercepts, I mean rational, so all we can do is x minus 4 out here. But there's something left in here. You can't just do x minus 4, and then you can't, round these off. What's left? We're going to use the concept of the distributive property. So x is going to get distributed through here 3 times, and then -4 is going to get distributed 3 times. And we're going to do that product, add up all those terms, and then we're going to get this. But I'm going to show you a way to do a front end and a back end, and then just one of the checks for either x squared or x to figure this out. I know this has to be x squared, and I know this has to be plus 1 on the end. So what I'm saying, you're going to get a quadratic in here. How did I know x squared and plus 1 on the end? Because the first 2, there's going to be 6 products when we do this, has to give me x to the third. There's no common factor. And then the last product, as we distribute -4 through, there's an x term here. -4 times, or 1 times something is -4. That would have to be 1 out here. I should say -4 times something is -4. That has to be a positive 1. So you're looking at this front end and this back end product. Now what about what goes in here? So here's what we do. I kind of call it the smiley, a little bit of a smiley face here. This product and then this product. When we add them together, has to give positive 4x squared. We have a negative 4x squared on that product there. This has to be 8x. Because when we do out all these products, this is 8x squared, and the product of these two is minus 4x squared. There's the advertisement again. What about the other one? What about the negative 31x? Well, that's this product, 1x, and then this product, negative 32x. But I just look at this inner product here and then this one to figure out what should go. Now this is an extension beyond the norm, but it is the concept of something that's called partially factorable. Problem 5, you get 4 again as the only one. It just works that way. It's not always 4. It just works that way. This has to be x squared. because x times x squared is x to the third. Negative 4 times something is negative 28. That has to be plus 7. This product here, negative 4x squared, plus this product has to give me negative 3x squared. This has to be 1x. Because 1x squared plus negative 4x squared is the negative 3x squared. What about the other one? So it's 7x minus 4x. 7x minus 4, when you do out all those products. So you have x to the third is the first one, and then you do these other two, and minus 4x squared minus 4x minus 28. So I'm just looking at the partial products in there. Okay, so that's that assignment. There's one more factoring assignment to do, and then we'll get into solving by factoring.